I had already given the PDF where I clearly said that the question number 9 to 12 I'm going to solve. So let's see first one. So that the relations are in the set A, X is belonging to Z, where the range is between 0 to 12. Now see the first question are equal to A, B, where mod of A minus B is a multiple of 4, and number 2 are equal to A, B, A equal to B are equivalence relations. That means so we need to show that it may be it should be reflexive, symmetric and transitive. After that you have to find out the elements those who are related to 1 or logot jigita connect hoi thake hegita element kun keta like here pora 0 pora jema 12 hole likim tetia khudise all the element related to 1 in each other case. So after solving the maths you will get it. So let's see here. Let capital A is equal to X belonging to Z and 0 is less than or equal to X less than or equal to 12. Now capital A, that means X or common hoye ase 0 to r to X or common hoye ase 12 to. So ultimately the value should be 0, 1, 2, 3, 4, 5 up to 12. Now the first relations has given us A minus AB. The order pair has AB and mod of A minus B is a multiple of 4. That's a multiple of 4. So we need to suppose it's A, again it's A cross A, all the suppose 0 to 12 we have taken all those value because the starting value is 0 and the end up value is 12, 0 to 12. So the ordered pair, the value will be like this: 0 0 1 1 2 2 12 12 1 5 5 1. Why it was? Because relations to relations to ama ki dia ase mod of A minus B. 0 minus 0 jodi 0 0 lo 0 to eta ki hoy multiple hoy 4 or it's a multiple of 4. 1 minus 1 again 0 we will get 2 minus 2 again we will get 12 minus 12 again we will get 0. So those are the multiple of 4. And 1 5 5 1, you see 1 minus 5, that means minus 4. Mod of minus 4 means plus 4. That's also a multiple of 4. Okay, again 5 1, after you have to subtract it 5 from 1, then again you will get 4, and that's also a multiple of 4. So A2 relations. So from here we need to show that whether it was reflexive, symmetric or transitive. 1 1 2 2 12 12 belonging to R, clearly it is reflexives because all those elements I had already said that the elements should be equal for reflexives. 1 1 2 2 12 12, those all the elements are the equal. Like if the elements be like this, then it will be belonging to R. That means it was reflexive. And as well as 1 minus 1 2 minus 2 12 minus 2, all the elements is a multiple of 4. Okay, so that's why R is reflexive. Now 1 5 is belonging to R. For symmetric we knew that if 1 5 5 1 should be belonging to R, so A in the first position, B in the second position. So for symmetricity, B should be in the first position, then A should be in the second position. So AB belonging to R, then BA also exists in here. So that's why it was symmetric. So it was clearly say again let we know that we 1 5 5 1 also belonging to R. In the relations it has existed. So this is the first element, second element, third element, fourth element. So 1 1 should be belonging to R. We know that 1 1 also we have got in the relation. That's why R is transitive. So hence R is an equivalence relations, and is an equivalence relations. Why it was equivalence relations? So all the condition has satisfied in here. The set of all element is related to 1 is 159. Here asking the questions in the last phrase that find the set of all element related to 1 in each case. মানে 0 পৰা যেতিয়া আমি 12 লৈকে 0 পৰা যেতিয়া আমি 12 লৈকে লৈছিলো গুটেইটা কোনটো 1 ৰ লগত কানেক্টেড হৈ আছে খুদিছে হা তো সোয়া 1 minus 1 0 is a multiple of definitely 1 to connect হৈ আছে. That's why we have right here 1 minus 5 4 পাইছো 4 also multiple of 5. 1 minus 8 8 also a multiple of 4. In case of the others elements you can see here 2 1 minus 2 is equal to 1 ahibo, 1 minus 3 is equal to kiman ahibo 2 ahibo. Those are not the multiple of 4. That's why we have right here only 159 are existed in here. I think you got it. And the second question is asked that R equal to A comma B, where A equal to B. The ordered pairs are equal. It is very easy. So ordered pair equal means 0 0 1 1 2 2 3 3 12 12. All this element will be like that. then 0 0 1 1 12 12 all those elements are belonging to R. So R is reflexive because as I said that 1 1 2 2 those elements, so like A. So if the element should be like that, if the ordered pair be like that, then we can say that it is reflexive. Yeah, again the condition has given A equal to B. A equal to B means 1 1 2 2 elements be like that. So for this case, you see 1 equal to 1, 2 equal to 2, 3 equal to 3, A equal to B, the condition. So that's why it is clearly said that BA is also belonging to R. If 1 1 is belonging to R, because A equal to B, then B equal to A, that means B comma A also belonging to R. That's why it is symmetric. For transitivity, we know that AB belonging to R and 1 1 belonging to R. So R is transitive and R is an equivalence relations, because when the conditions be like that, you don't need to explain anything else. You just write it was symmetric, transitive, and reflexives because the elements are equal. So I had already discussed in the previous demo class. It says give an example of the relations which are symmetric but neither reflexive nor transitive. Okay, I will discuss only one maths, and rest of the maths you can do the homework. Baki geta koriba. Okay, I will discuss the first one. First one is A equal to 5 6 7 derived that. Suppose we have to assume 3 element 5 6 7. From here we are write the ordered pair. The ordered pair in the relation is 5 6 6 5. So it was not reflexive. So why it was not reflexive? We have only get the elements equal, like 5 comma 5 6 comma 6. Doesn't that kind of element was not existence in this relation. That's why it cannot be reflexive. It was definitely symmetric, because we know that 5 6 is belonging to R, then 6 5 also belonging to R. That's why it was symmetric. And for transitivity, 5 6 6 5 belonging to R, then first and fourth element should be belonging to R. It should be existed under relations. So but 5 5 doesn't belonging to under relations. So have you got like that kind of value in here? You haven't. So that's why it cannot be transitive. Hence the relation are symmetric but neither reflexive nor transitive. So rest of the maths, so you can do in your home. So I will discuss the number 12. Show that the relations are defined in the set of A. Triangles are T1, T2, T1 is similar to T2, is an equivalence relations. So this is the relations given. Eight relations amak dia ase, eight relation or ami uliabole lage je equivalence relation hoy ne nohoy. Tar pisot ki koise je consider three right angles T1 with the sides 3 4 5. T1 amak right angle eta dia ase, T1 er sides dia ase 3 4 5, T2 sides 5 12 13, and T3 with the sides 6 8 10. Which triangle among T1 T2 are related? So after that we need to find out the among those three triangles which are related to each other. Okay, so first of all, so we write the relations here. Here T1 T2, T1 is similar to T2. So when it was in the same place, when it was in the same work, when similar, then it must be reflexive, because T1 is similar to T2. So definitely T1 so R is reflexive, since every triangle is similar to itself. Definitely every triangle is similar to itself. So that's why T1 which is belonging to R, T2 which is belonging to R. Okay, next, if it was similar, then T1 T2 belonging to R, because T1 is similar to T2. So it is clearly said in the questions. So if T1 is similar, T1 to T2 common hoy, similar hoy, then T2 T1 common hobo. T2 is similar to T1, so T2, the reverse was satisfying in here. So ultimately the R is symmetric. And again, if from the symmetric case, suppose T1 T2 T2 T3 belonging to R. Okay, jodi T1 to T2 similar hoy, T2 to T3 similar hoy, then T1 also similar to T3. So T1 is similar to T3. So T1 T3 ke belongs. So R is an equivalence relations, because it was transitive hoy, symmetric and reflexive hoy. All those criteria has satisfied. That's why it has an equivalence relations. Now from the above, we observe that 3 by 6, 4 by 5, 5 by 10. Why? See here, 3 by 6. Those sides are T1 sides. T1 side is 3 4 5. T3 side is 6 8 10. 3 by 5, 4 by 8, and 5 by 10. Okay. So here clearly we have written here 3 by 6, 4 by 8, 5 by 10. That means we have get the same value, half. So ultimately T1 is completely related to T3 in the same ratio. Okay. And in the next class, once the relation function was finished, I will discuss the ZW main and advance some of the maths in here. So first of all, we need to learn the concept from relations and relations and functions.